Hi everyone, this is me again, Teacher Lei, and for today's video, this is the second. The first one is the lesson about inductive and deductive reasoning. So for this time, I have to discuss the law of detachment and law of syllogism, which is part of the deductive reasoning. Okay, in deductive reasoning, we have these two laws. Let us talk about it. Let's say Lemur Sena is a judge, okay? And a judge must be able to organize information in a logical order and arrive at valid conclusions, right? That is the work of a judge. If you know someone who's judge, maybe your parents or your aunties, your godparents, or whosoever you know, this is their job, okay? They have to organize information in a logical order. Now, if you want to be a judge someday, you need to be logical, okay? Think logically. So, this lesson will help us have our basis, okay? Foundation knowledge about logical thinking. And that is inductive reasoning and these two laws, okay? Now, here's the situation. Lamar is a judge. Now, Lamar uses the logic of conditional statements in his profession. Okay? Logic of conditional statements. You know what is conditional statements? Yes, the if-then statements. In high school, geometry, which is our next topic for the next quarter, he also studied if-then statements. Okay, we're done with it. Right, class? Now, he knows that if conditional is true and its hypothesis is true, then its conclusion is also true. We know that already. Now, Lamar is considering two sets of statements in a case to which he is assigned. Here's the first statement. If a person runs a red light, then the person breaks the law. Statement 2, Lisa ran a red light. So what can we conclude given these two true statements? How are we going to help Lamar, okay, the judge, in concluding, okay, given these two statements? So we can help him, right? So what can we conclude, class? We can conclude that Laser broke the law, okay? Since he ran a red light and if a person runs a red light, the person breaks the law. So we conclude that Laser, again, broke the law. Okay, that's how we conclude. Okay, now another. Lamar knows that here's the given statements. Lamar knows that both statements are true. By combining the statements, he can make that's he, not she. He can make a valid conclusion that Laser broke the law, right? So, and this type of reasoning is called law of detachment. Okay, this is so-called law of detachment. Concluding, okay, based on the truthfulness of the first two statements. Now here is another information about law of detachment. It is frequently used in arriving at conclusions in geometry. So I'm so excited for our next quarter because our third quarter will be all about geometry. Okay, so be excited as well. Be with me. Let's continue. Now, what is law of detachment? Law of detachment, class. If P implies Q is a true conditional and P is true, then Q is true. I hope you get this. Again, if the hypothesis that implies the conclusion is a true conditional and P is true, the hypothesis is true, then we can conclude that the conclusion is true. Okay? Next. In logic, this law is written as, here it is. And how are we going to read this? Okay, take note of the symbol. We have P implies Q and P is true, then Q is also true. Okay? Again, this states if P implies Q and P is true, then Q is true. Okay? How about suppose another suspect is entered into Lamer's case? Okay, another person. Now, it is known that Luffy broke the law. Luffy entered this case. Luffy broke the law. That's just the statement. Luffy broke the law. Can I, or let's say me, Lamar, can he automatically conclude that Luffy also ran a red light? And of course, the answer is no. We cannot conclude, even though Luffy broke the law, we cannot conclude that the same thing with Laser, he broke the law. No, we cannot conclude that. So, with that, this does not follow from the law of detachment. You get it? Okay, very good. Let's proceed with another law. This law of syllogism states that if P implies Q and Q implies R are true conditionals, take note, P implies Q and Q implies R are true conditionals, then P implies R is also true. And it is very similar to the ideas in transitive property of equality. If you're familiar, and I hope yes, since grade 7, you must be familiar with this. And a lot of properties of equality will be discussed on the third quarter. So let's wait for it for the next quarter. A lot of properties, definitions, undefined terms, the postulates, theorems, all of them will be discussed in geometry. And I hope you study in advance about them. Okay, let's continue. Here it is. Recall transitive property of equality, which states that if A is equal to B and B is equal to C, then A is equal to C, right? So wait for the next video on different properties of equality, like what I've said before. Here, consider the following three statements. What is it? Let S, R, and P represent each of the statements. Okay, for the first statement, we have S, a figure is a square, a figure is a rectangle, then a figure is parallelogram. Okay, we have S, R, P. Now, here are the figures. So, we're going to combine the statements to make this conditional. So, let's say S implies R. How we're going to combine this? So, it will be, if a figure is a square, then it is a rectangle. If a figure is a rectangle, then it is a parallelogram. Then S implies P. If a figure is square, then it is parallelogram. Take note, these two are correct. If a figure is square, then it is rectangular. And then if a figure is rectangular, then it is parallelogram. They are two true conditionals, right? So with the law of detachment, okay, given that the first two conditionals are true, with the help of the law of detachment, we can conclude that the third conditional is also true. That if a figure is a square, then it is a parallelogram. And that's, yes, that's true. Listen to this, class. The patterns outlined in the law of detachment, the law of syllogism, and other laws of logic can be combined to provide a system by which you can reach logical conclusions. This system is called deductive reasoning. Deductive reasoning is one of the cornerstones in the study of geometry. As in order to arrive at a conclusion by using deductive reasoning, you must use previously established statements that are true. So to start our system in geometry, we must rely on statements that are accepted to be true. And these are definitions, postulates. We also rely on our list of undefined terms. If you don't know about list of undefined terms, you will learn it. As you can see in the figure, okay, you have the point, the line, and the plane. These three are the undefined terms. That there are a lot of postulates about them, theorems about them. Okay, the new conclusions derived using deductive thinking along with undefined terms, definitions, and postulates are often called theorems. Now, theorems should be proved before they are accepted as true. So, expect that we will be proving, okay? We will be proving here theorems. Okay, that's why the title of this week lesson is proofs, because we're about to make proofs. Okay. However, once proved, a theorem becomes another tool that can be used in the system of deductive reasoning to develop even more theorems. So, meaning there are so many definitions, postulates, theorems that we're about to learn from this uh, geometry lesson next quarter. So expect a lot of these definitions, postulates, and theorems. Memorize them all. So here, I just get a book, a title of the book, 18 Theorems of Geometry for High School Students. So William Smith. So there are a lot of them. Okay, actually, yes. I think this will be all for the discussion. Now let's try some. Use the law of detachment and law of syllogism to write a valid conclusion from the two given statements. If no valid conclusions exist, write not possible. Okay? Okay, so given this, statement number 1, all mammals have ears. Statement 2, cats are mammals. So what can we conclude? Very good. We can conclude that cats have ears. Nice one. Next, another example. The same thing. Use the law of detachment and law of syllogism to write a valid conclusion. If no valid conclusion exists, write no possible. Statement 1. If x equals 7, then 2x minus 12 equals 2. And then statement number 2, 2x minus 12 equals 2. What can you conclude? Uh-huh. Yes. There is no possible. Okay? There's no possible conclusion. Okay? Why? Because here it is. If x equals 7, then 2x minus 12 equals 2. That second statement, 2x minus 12 equals 2, is the conclusion. Okay? So, there's no more other conclusion we can make from this. Only converse of the statement, interchanging the hypothesis and the conclusion, they're still the same. Okay? Not possible. Last one. All squares have 4 right angles. Then, if a figure has 4 right angles, then it is a quadrilateral. We can conclude that if a figure is square, then it is a quadrilateral. And again, if you want another additional point in your performance, okay, yeah, use the law of detachment, the same instruction. Here it is. Answer this, okay? Make a possible conclusion, not possible, but a valid conclusion. And then, that's it. If now, valid conclusion, right, not possible. Okay, submit via FB Messenger class. That will be all, and goodbye. Thank you very much.